Hi everyone, welcome back. This is the 18th video in our series on building a chess engine from scratch in the Java programming language. I've gotten a lot of feedback about finding the finished source code for this, and I've commented back to folks who were interested in that, and I pointed them to my GitHub repository where the code exists. Before we jump into today's video, which is going to be a continuation of the player class and fleshing out the player class, the white player and the black player, I did want to just sort of do a really quick demo of the finished product. Or, it's never really finished, it's always sort of a work in progress, but I just wanted to show you guys something with a working GUI so you can get a feel for it. And feel free to give me feedback in the comment box. So here we are. This is the game, and we can, what I'm going to do? I'm going to sort of do a setup, and I'm going to have it play computer versus computer, and then we'll come walk through it. So I actually have a book of about 1 million games that I downloaded that act as part of the opening book sequence. So you can see the query into my database for those, and I'll explain that all in a future video. But what you're going to see is about 12 or 13 book moves, and then after the book moves are completed, we will fall out of book, and then we'll see our AI searching for moves on its own. So we're still in book here. I'm not really a chess theorist, so I can't comment too much about the actual play, but each side is making moves from the book that it deems are good moves, and the book will shrink. So far we have about 39,000 hits in the book, 21,000. This is going to quickly go down. There we go, and now we're out of the book, and we're actually searching. So yeah, so anyway, I wanted to just do that quick demo for you guys, and if you guys have any questions or comments on that, please do let me know. Alright, so we're here, back in the player class here, and I've noticed that in my videos I'm not giving enough real estate here to the IDE, so I'm going to expand out the IDE a little bit, give us a little bit more room to work with. And there are a few methods that I want to flesh out here on the player class. So we have defined one method that's abstract, that's resolved polymorphically, get active pieces, and that behavior is defined on black player and white player polymorphically to return the board's black pieces or white pieces. I also want to introduce on here another method called public abstract alliance get alliance. This is going to be something very similar here. Let's let the IDE help us. So black player, we're going to say alliance.black. And for white player, we're going to say alliance.white. Okay, great. Let's also define a method called getOpponent. Public abstract player getOpponent, and we're going to come back here and we're going to implement this method. And we're going to say this dot board dot. So if you are the hold on, let's return null for now. I'll need a little bit more to flesh this out. Return null. And for white player, let's get rid of the compiler error. What's going on? There we go. Let's return null. So I think that's good enough for now. Let's so what we're going to say here is this dot board dot. So if I'm white, I want to have a method called black player. And if I'm black, I want to have a method called return this dot board dot white player. So we need to go back to the board, and we're keeping track of these now. So we want to be able to say public player white player, return this dot white player, and public player black player, return this dot black player. Be careful not to put the method here, otherwise it'll be a recursive method that invokes itself forever. That's not what you want. Alright, so let's see, we still have a compiler error here. Oh, now we're fine. Okay, so these are some of the helper routines that we wanted to implement before we flesh this out more. Let's go here and continue along this line. We're going to have a public method on here called public boolean is move legal, and we're going to pass it a move. And really for now we can just say this dot legal moves dot contains move, and we haven't really fleshed out anything about the move class that's going to help resolve this, but you can see what we're testing here. We're just testing if the move that's being passed in is contained in this player's legal move collection. And we're going to have other methods defined on here as well. Let's see. We're just going to put the form in for these methods, not the actual content. We'll do that in a future video. Public boolean is in check. That's going to be really important. Let's just return false for now. Public boolean is in checkmate. That's going to return false for now. And public boolean is in stalemate. So we still need to implement these methods, obviously. Right? And public boolean, oops, is castled. So these are going to be important messages that we need to flesh out. And really the most important method on here is going to be public, and we're going to introduce a new class called move transition. Make move final move. And we're just going to say return null for now. And this class doesn't exist. We need to create this class, move transition. And move transition really just represents, you know, when you make a move, the transition from one board to another and all the information that you want to carry forth in that. So really, the kind of things that we want to capture in a move transition are the transition board, right? So the board that you're going to transition to after you make the move. So private final board transition board. final move private, final move, and private final move status. And that's really, move status is going to tell us whether we were able to do the move or whether we were not able to do the move because, you know, it leaves us in check, or it's not a legal move, or whatever. Right, so let's import the classes that we need to import. And let's create the class we need to create. It's going to be a move status is going to be an enum, and let's leave it here in this package for now. We're probably going to move it later, but we'll just keep it here for now. So now it's complaining because we haven't declared these inside of a constructor. So public move transition. We're going to say final board, transition board, final move, final move status, We'll say this dot transition board is equal to transition board. This dot move is equal to move. This dot move status is equal to move status. Okay. So when we make a move, we're going to return a move transition, which is going to wrap the board that we transition to. You know, if the move was able to, if we were able to actually make the move, if the move status is done. All right, so what have we done so far? We have introduced several methods that need to be fleshed out here on the player class. We have introduced a couple of new abstract methods that are polymorphically determined based on whether you're white player or black player. And this is going to be critical for us. So I think I'm going to stop here, and I'm going to continue in the next, so we'll have maybe 1 or 2 more videos on the player class, and then I will we'll probably start working on a rudimentary GUI, and then we'll go back afterwards, do the moves, you know, finish out all the moves. Actually, before we do the GUI, we should do the move classes and implement the execution of moves. Then after we do the moves, we'll do the rudimentary GUI, and then from there we'll move on to the artificial intelligence segment. The only other thing I want to say is that the focus of this engine is simplicity and readability. This is by no means the optimal way to build a chess engine. So we'll talk about how strategies for doing that in future videos, and maybe if there's interest, we'll you know, create a new series on building a more advanced modern chess engine. The focus here really is on learning, simplicity, and you know, a decent engine that can play well but not great. Okay, thanks so much.